Hello, 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 and welcome to another episode of Mr. Boskin Does Some Math. Today we're doing illustrative math, grade 8, unit 4, lesson 13 practice problems. Our first question here says write the equations for the lines shown. So we have two lines. The black line and the blue line. For the black line, our slope, if we find a couple of nice points, looks like we have a rise of 3 and a run of 1. 3 over 1 is 3. Our y-intercept is 2. And the blue line, find a couple of nice points. Looks like a rise of 3 and a run of 1, but it's going down. And our y-intercept looks like 8. Okay. Describe how to find the solution to the corresponding system by looking at the graph. So, solution to a system of equations is a value of x and y. Like the solution to one equation is the value of x. The solution to a system of equations is an x and y value. It is a point. This solution, the spot where both of those are true, is right here, which is the point 1, 5. So how do we find that? We look for the intersection of the 2 points. Or intersection of the 2 lines, rather. Okay. Describe how to find the solution to the corresponding system using the equations. So we have 3x plus 2 and negative 3x plus 8. How do we find the solution? Well, we want to know where their x and y values are both the same, which means we can set the 2 equations equal to each other, which means their y values will be the same, and find the x value where that's true for both of them. So how do we do it? 3x plus, what was that? 2? Yeah. 3x plus 2 equals negative 3x plus 8, and then solve. And I bet the solution will be 1, 5. The solution to a system of equations is the point 519. Choose 2 equations that might make up the system. So how do we know if this point is a solution? Well, what we have to do is see if this point lies on the line. That means one of the lines could work, and what we're going to have to do to find 2 equations is find 2 lines where this point works. So the first one here, if we plug in our x value into each of those, we want to get a y value of 19, or negative 19. Negative 3 times 5 is negative 15. Subtract 6 is negative 21. That's not negative 19. That one can't work. Okay, 2 times 5 is 10. Subtract 23 would be negative 13, so that can't work. Negative 7x plus 16. Negative 7x is 35. Negative 35 plus 16. Well, that is negative 19. So C can work. X subtract 17. 5 subtract 19. 5 subtract 19 is negative 14. That's not negative 19. That won't work. Negative 2x subtract 9. Negative 2 times 5 is negative 10. Subtract 9 is negative 19. So choose two equations that might make up the system, C and E. Question 3, solve the system of equations. Okay, if y equals 4x subtract 3 and y equals negative 2x plus 9, how do we find where both of these are true? Well, we set them equal to each other. So 4x minus 3 equals negative 2x plus 9. Now, let's get all the x's on one side. The left has more, so let's get rid of them from the right. How do we get rid of subtracting 2 x's? We add 2 x's. Do it to one side, we have to do it to the other. Those cancel, and 4x plus 2x is 6x. Subtract 3 equals 9. Now all the x's are on the left, so let's get all the numbers on the right. How do we get rid of subtracting 3? We add 3. Do it to one side, we do it to the other. 6x equals 12. That is a horrible looking 12. Okay, 6x equals 12. Now what's stopping the x from being by itself? The 6. The 6 times x is multiplied. To undo multiplication, we divide. Do it to one side, do it to the other. Those will cancel. We're left with x equals 12 divided by 6 is 2. We're done, right? We found x? No, we are not. The solution to a system of equations is a point, an x and y value. We found x, now we have to find y. So if we plug that back in, which one should we plug it into to check? Both of them. That's how we know we did it right. So y equals 4 times 2 minus 3, and y equals negative 2 times 2 plus 9. We should get the same solution for both of these. 4 times 2 is 8. Subtract 3 is 5. Negative 2 times 2 is negative 4. Negative 4 plus 9 is 5. Okay, we got the same value. That means we did it correctly. So the solution to a system of equations is a point, an x and y value. Our x value is 2. Our y value is 5. Solve the system of equations. Ooh, it's kind of just like the last one. So to find the solution, we have to set the two of them equal to each other. 5/4 x minus 2 equals negative 1/4 x plus 19. I see more x's on the left, so let's get rid of them on the right. How do we get rid of a negative quarter of an x? We add a quarter of an x. Those cancel. 5/4 plus 1/4 is 6/4. X minus 2 equals 19. Now, what do? We got to get rid of the 2 because we've got all the x's on the left, so we want all the numbers on the right. Add 2 to each side. Those will cancel. 6/4 x equals 21. Now, how do we get the x by itself? It's being multiplied by 6/4. So we divide by 6/4. Those will cancel. X equals, well, what's 21 divided by 6/4? I'll do it up over here. 21, we're dividing by a fraction, so I'll write that as a fraction. Dividing by a fraction means we multiply by the reciprocal, which means we multiply by 4/6. But we can simplify that fraction. Let's simplify before we multiply. 6/4 is 2/3. So we're multiplying by 2/3. 21 times 2 is 42/3. If we simplify 42/3, that is 14? Yeah, 14. So x equals 14. Now, if x equals 14, what does y equal? Y equals 5/4 times 14 minus 2. So y equals 5/4 times 14, 17.5, minus 2, 15.5. Now let's check the other one. Y equals negative 1/4 times 14 plus 19, which means y equals negative 1/4 times 14 plus 19, 15.5. So solution to a system of equations is a point. This is the point 14, 15.5. Here's an equation. 15 times x minus 3 all over 5 equals 3 times 2x minus 3. Solve the equation using the distributive property first. Okay, so I'll write out the equation. 15 times x minus 3 all over 3 equals 3 times 2x minus 3. Using the distributive property, well, 15 times 3, or 15 times x is 15x. 15 times 3 is 45 all over 3 equals, distribute this, 3 times 2x is 6x. 3 times negative 3 is negative 9. Now what do we want to do? Both of these numbers here are divisible by 3, so let's do that. 15x divided by 3 is 5x. 45 divided by 3 is 15. And equals 6x minus 9. Hang on a second. I copied the equation down wrong. That's not a 3, that's a 5. which means that's a 5, which means I need to remember how to erase. Okay, I'm back. Sorry about that. Edited out some trash. I had 3 here. I changed it to 5 because I had copied the equation down wrong. Now let's divide by 5. 15x divided by 5 is 3x, and negative 45 divided by 5 is negative 9, equals 6x minus 9. I'll write this up here again. 3x minus 9 equals 6x minus 9. I don't know what I did over there. Let me get rid of that. Having all kinds of problems today. Okay, 3x minus 9 equals 6x minus 9. Let's get all the x's on one side. There's more on the right, so I'll take away 3x from this side, so I'll take 3x away from that side. Those cancel. Negative 9 equals 3x minus 9. Add 9 to get rid of that, which means I'll add 9 to get rid of that. Those will cancel. Ooh, those also cancel. 0 equals 3x. If I divide each side by 3, I know that x equals 0. Okay, now solve the equation without using the distributive property. So 15 times x minus 3 equals 3 times 2x minus 3. And that is divided by 5. Okay, how are we going to do this? We can't distribute anything, but if I look at this, 15 divided by 5. What is 15 divided by 5? Well, that's 3. So that means we have 3 times x minus 3 equals 3 times 2x minus 3. Now, this whole side's multiplied by 3. This whole side's also multiplied by 3, so I can divide everything by 3. Those cancel, those cancel. I'm left with x minus 3 equals 2x minus 3. Get all the x's on the same side. There's more of them on the right. So I'll subtract an x from here, which means I have to do it to the other side. Those will cancel. Negative 3 equals 2. Nope. 2x minus x is 1x. Now, x's are all on the right, so I got to get rid of the numbers on the right. So I'll add 3, do it to one side, do it to the other. Negative 3 plus 3 is 0, equals x. Ooh. Same solution for both. Now, the next question here says, check your solution. So, to check our solution, I'm going to just bring it down here. I copied and pasted that, so I can just stick it there. Now, I want to try checking my solution, which means plugging in my solution. 15 times 0 minus 3 all over 5 equals 3 times 2 times x, which is 0, minus 3. Now, follow our order of operations. 0 minus 3 is negative 3. 15 times negative 3 all over 5 equals 2 times 0 is 0, minus 3 is negative 3. Okay? 15 times negative 3 is negative 45 over 5 equals 3 times negative 3 is negative 9. Now let's check this side. Negative 45 divided by 5 is negative 9. Does negative 9 equal negative 9? Yes, it does. That's a big old check mark. I love it when I check my work and it works out right. Okay, this has been another episode of Mr. Boskin Does Some Math. Thanks for watching, and we'll see you next time.